Cavitation. What is cavitation? What is cavitation damage? How to prevent cavitation damage in hydraulic structures. Cavitation is a process of nucleation in a liquid when the pressure falls below the vapor pressure. Considering the phase diagram, pressure versus temperature for water, with the absolute pressure on vertical axis, the temperature in horizontal axis, the blue line in the phase diagram shows the vapor pressure. Considering some water at ambient pressure, a sudden drop in pressure would lead to cavitation. It is basically the rupture of the liquid by decreasing the pressure at a constant temperature, leading to the formation of vapor bubbles, also called cavitation bubbles, which may collapse and implode when advected in regions of higher pressures. This photograph illustrates a cavitating foil with the flow from the right to the left, and we see the advected cavitation bubbles. On this close-up, we see the formation of cavitation bubble, a very rapid process, on the extradose of the foil. Cavitation is associated with noise, loss of efficiency, and damage to turbines, including hydroturbines, as illustrated on these two photographs, but also ship propellers and hydrofoils. What is cavitation damage? Cavitation damage is caused by the implosion of vapor pressure bubbles in a region of higher pressure, which can lead to extremely large and violent pressure transients. The collapse of cavitation bubble is associated with a very violent process which can lead to extreme pressure in excess of 1,500 megapascal. That could lead to the initiation of some damage called cavitation pitting. Considering a protruding joint along a concrete invert, separation and local fluid acceleration may take place at the joint, which will be associated immediately downstream to a sudden decrease in fluid pressure because of the Bernoulli principle. And when the fluid pressure decreases below the vapor pressure, cavitation bubble will form. And when they implode close to the downstream boundary, they may damage the invert. Example of extreme erosion is a big hole at Plain Canyon Dam, where the scour hole was initiated by cavitation pitting. How to prevent cavitation damage in hydraulic structure and dam spillways? As a rule of thumb, on chute spillways, cavitation damage may occur for velocity greater than 15 to 20 meters per second. Mitigation measures may include very strict invert surface tolerance, but there are some limitations. The use of high resistance concrete, including fiber reinforced concrete and polymer concrete, or the use of steel lining. But by far, the most reliable mitigation measure is the aeration of the flow. The aeration of the flow will increase the compressibility of the liquid by the presence of the air bubble, and in turn lead to a massive reduction in the transient shock wave and pressure. Aeration could be in the form of self-aeration, but most often we will artificially introduce air through a bottom aeration device or bottom aeration slot. With a few examples here, on the left we see the two chimneys feeding the air slot at the Paradela Dam in Portugal, and on the right we see the aeration slot along the Crotty Dam spillway in Australia. In summary, cavitation is the formation of vapor bubbles caused by a massive drop in absolute pressure for a constant temperature. Advected cavitation bubbles may implode in regions of higher pressure, generating extreme transients, and when the cavitation bubble implosion occurs next to a solid boundary, it may initiate damage, in turn leading to larger erosion and scar. Relevant references, including a number of seminal textbooks. Additional reference on air slot and on cavitation on spillways. Acknowledgement. Thank you very much.